start. Oh, you know what? It's probably, I think this is literally PEMDOS messing me up. Okay. Hey, I'm Jasdev, and I'm a product engineer at the browser company. And you may have noticed in the next release that we actually shipped a new loading indicator. And that's this little guy that sits above your Arc window, pulses in and out when things are loading. And if things are taking a particularly long time, it starts to race across the track. So this is a really fun view because we actually implemented it entirely in SwiftUI. And even though we did pick SwiftUI, there's actually a bunch of different approaches. So that's why we're making this video. We wanted to see how y'all would approach making this loading indicator, and we wanted to provide a sketch of our implementation and use that as a starting off point for y'all to drop comments below and kind of see how you'd implement it. So we definitely won't cover everything, but we'll give you a skeleton of how we approach the loader, and yeah, we'll go from there. It'll be really fun. So to start, I have a empty SwiftUI Mac app with two buttons, start and stop, wired up to a SwiftUI Views view model. So the approach we ended up taking, we actually initially started out in a different direction where the usual approach to kind of repeating forever animations in SwiftUI is to use SwiftUI's repeat forever method on the animation type. And while we initially took this approach, that worked if like loading worked like completely like perfectly, where like there was no interrupt in between phases. But we found that actually a repeating forever animation was really tricky when we needed to kind of, when loading stopped mid-phase and we needed to transition smoothly. So then we actually changed course and approached it using SwiftUI's timeline view. And timeline view is a relatively new API, came out in macOS 12. And what's awesome is that it lets you render a SwiftUI view on a schedule. And namely, there's actually an animation schedule that lets you keep things very smooth. So let's go ahead and just sketch out that implementation, kind of show you all how it looks. So to start, there's two phases to this animation. The first phase is kind of that pulse in and out opacity fade. And then the second phase is where you race across the track. So let's take this one step at a time. So the way we approach this is we actually did a Z stack of two capsules. So we got capsule, we'll give it a continuous rounding style, and then to start we'll fill it with color dot gray. And then we'll give the entire thing a frame just as an expand out into the ether. Width 80 and height of say 4. If we go ahead and run this, cool, we got a little loader to start with. So yeah, now let's tuck this away in a timeline view. So timeline view takes two arguments. It takes a schedule, so we'll use that aforementioned animation schedule, and then a content closure. So I'll go ahead and move that Z stack into it here, and then this closure takes in a context, and this context actually provides the current moment in time. That's that context.date. So we can use this date relative to some start date and kind of keyframe this animation through both phases. So let's go ahead and do that. So let's have it that when the viewModel start loading method gets called, we'll save a start date. So we'll have a published property called start date. That's an optional date. And then when we start loading, we'll say start date equals the current moment, and say for now stop loading, and we'll leave it as an exercise of the viewer to do like proper stopping when we kind of interrupt the phase, but we can just say start date equals nil then. And we'll add a little computer property to make things a little more convenient, where we can say like animation paused, and we'll say the animation should pause if start date is nil. And why that's needed is because this animation schedule actually has a paused argument. So we can tell it to pause when the view model is saying the animation is paused, because we kind of just don't want this timeline view to keep re-rendering into the ether. And then from there, we can then say, okay, let's tackle the first phase. So that's that opacity fade from 0 to 1 back to 0 into 1. And let's have that basically take half a second for each fade. So we'll do half a second to fade from 0 to 1, and then half a second to go from 1 to 0. So to do that, let's go ahead and sketch that out. So we can say like, get the current elapsed time, and that'll be the current moment and time interval since, and then that kind of reference date we saved in the view model. So the view model, that's start date, and if it's not present, we'll just say now. And what we can do is we want to basically use that to derive an opacity for this bottommost capsule, which will do the opacity fade, and then we'll stack another capsule on top to do that racing across the track. So we'll say opacity, and to calculate the opacity, let's give a little private helper here on the side. We'll call it track opacity, given some elapsed time, returning a CG float. And Now let's like tuck away some duration values for both of the phases. So we can say first phase, we'll add a little namespace for it. We can say static, let like opacity, fade duration, time interval, and say equals 0.5. And then we can maybe say like the overall duration is 2 seconds, and then we can do that equals 2. So what we want to do here is like, we want to fade in and then out and then in and out, so kind of just alternating in that fashion. And then, so to start, we'll just have that kind of repeat forever just to demonstrate how this would work. So we can basically say we need to figure out if okay. So what we'll do is we can say like let opacity equals elapsed, get the remainder after dividing by first phase dot opacity fade duration, and then so that'll kind of like give us the remainder after dividing by 0.5. But then we want to fade in and then out and then in and then out. So we kind of need to alternate this value between like just returning opacity and then 1 minus opacity on the fade out. So we can do return. And so we need to figure out like how many, like which are we on, like an odd or even cycle. So we can do elapsed divided by first phase dot duration, and then if it is a multiple of 2, then we return opacity, else we return 1 minus opacity. So that'll give us the effect of like on the first we'll rise up to 1, and then on the second we'll kind of fall back from 1. So let's do track opacity here, and then thread through elapsed. And cool, let's go ahead and give this a try. So if we hit start, okay, so I see. Okay, so we actually need to do opacity is that remainder divided by that first duration. That should give us some smooth ramp up and ramp down. There we go. Okay, cool. Because yeah, we basically get to normalize this range and make sure the opacity is like within 0 to 1, and then we can do this kind of rise up and fall. Cool. So that gives us this like fade in and out. This is kind of just happening continuously. So let's go ahead and now do the part where we transition into the second phase after a given period of time. So what we'll do is now we can say we got this first phase, we can do enum, second phase, and this one will actually give, instead of just being a simple namespace like that usual empty enum approach, we're actually going to have different cases here, and I'll explain this first. So we'll do first, second, third, and then we can say like static. Yeah, let's start there, and then what we want to do is, so let's say if we guard elapsed, so let's make sure that this is less than first phase dot duration, else let's have like a resting opacity of like 0.25, and then from there we can start to think about the second capsule. So let's go, and actually I think we can move this outside the timeline view, get the same effect. So now for the second capsule, to achieve that like racing effect, so let's actually first make sure, so like we can say like let is in second phase equals elapsed is greater than first phase dot duration, and we can just make sure this thing is hidden. So if we're in the second phase, yeah, it should be shown, else not. And then to kind of achieve this like racing across effect, the approach that we ended up taking, and this is kind of what we're curious about how you all approach it too, is we actually took this clip shape approach. So what we can do here is we want to clip, so what's awesome about clip shape is like it's going to clip the underlying view according to some like masking view. So what we'll do here is we'll take a rectangle over top, and we want to trim it from left to right. And then so what we'll do is we'll have like the rectangle grow from the leading to the trailing edge, then have that trailing edge side of the rectangle kind of follow, and then rest for a period of time. So what we'll do is like we'll go across at say 0.25 seconds and then have the tail follow up in 0.25 seconds and then kind of rest for 0.25 seconds. So what we can do to achieve that is kind of have this rectangle like phase across on top. So what we can do is we can trim and then we can give it like from, so say we do like 0 and then to 0.5. Let's go ahead and try this, and then instead let's just make it a little bit different. Let's just do color.black here, and let's go ahead and run this. And what's surprising here actually, and this is a quirk we'll work through, it turns out when you trim a given shape in SwiftUI, you have to kind of give like, it's in a normalized range from 0 to 1. So ideally, we'd love for the rectangle shape, when we say 0, to be from like the leading most edge, and 0.5 to be like it's drawn at like halfway. But it looks like the way that SwiftUI's rectangle shape draws its path, it doesn't kind of follow that kind of directionality that we want. So we actually need to make a custom shape that grows from left to right, or from like the leading to the trailing edge. So what we'll need to do is like, to achieve this effect, maybe let's make a custom shape. So we can do that at the bottom of this file here. And we can call it like, I don't know, leading to trailing, trailing rectangle, and that conforms to shape. Whoa, that was well. Conforms to shape. I literally have never seen that before. Okay, and then it has a path. So actually, if I builds, that should tell me. Oh, that's probably why it was path in. So what we can do here is let's have it kind of draw in the direction that we're expecting it. So we can say from is a CG float, and then to, and then to draw from the leading to the trailing edge, since SwiftUI's origin is in the upper left corner of the view. So in this rectangle, the upper left is the origin. So we basically want to say, we want to return a path. So we can say like var path equals path, and eventually we want to return it. And then what we can do here is let's start in, we could move to, and then we want to go to the start of this rectangle. So what we'll do is, let's do knit x, y, and then we want to go to rect.min x and rect.min y, and then so we'll move there, and at the end of the day we want to just like path.close subpath. But then, so okay, so starting at the upper left, so we want to move over to the top trailing side. So this always messes me up, so we'll probably need to do a couple things here. So add line to a point, and then what we want to do here is now we want to go to rect.minx plus, oh actually sorry, we need to do yeah, we want to go to the minx plus actually rect.width times from, so yeah, like say if we do like 0.5 to 1, we actually need to start from there. So rect.minx plus plus that plus dot 2. Actually, I think if we make the assumption that 2 is always greater than from, we should be good here. And then keep the y at min y. And then, so now we're in the upper right corner, and now we need to go to the bottom. So we'll do max y. And then now we need to come back to the bottom leading edge. So that'll be from and max y, and then closing that subpath should be good. So then now let's replace the clip shape with that, and let's see how this looks. So, oh, and then from and to moved to the initializer arguments there. So let's go ahead and run that. Let's see where we're at. So Fade. Cool, awesome. And then, so now we have like this clipping happening from leading to trailing. So now let's just make sure that works. So if we go from 0.5 to 1 and run this, should pulse in and out. Awesome, yeah, now we got the second one. So now this is where we need to go in the second phase animation. And we need to figure out how far into, so now we need to divide this up into phases. So let's start from growing from leading to trailing. Then we'll do the trailing kind of follows, and then we'll do that rest period. So what I'm trying to relate here, the idea is that in the second phase of the animation, there's kind of 3 ranges. We're gonna take 0.25 seconds to go from left to right, and then 0.25 seconds to go from right to left, and then rest, and kind of be invisible for 0.25 seconds. So we need to then compute. So then now, where I think this is gonna need to be a little bit more complicated. So then we'll say 0.contains elapsed. So we want to make sure actually those don't contain it, else return 0. And so what I mean by that is if we're in the first phase, we're growing from the left going towards the right. So that means the trim start, that from value is going to be 0. And then at that third phase is actually the resting phase, where this overlapping capsule is not present. We want it to also be 0, because we could basically trim from 0 to 0 to kind of have this resting phase. And then otherwise we want to return, so if now we're in the second phase, so return we want this to be a CG float. So trim start, let's give ourselves a little bit more room here. Cool. And then if we're in the second phase, we know the trim end will be 1 because we'll be growing towards the tail. And then we need to figure out how far along we are in the second phase. So that'll be, and we need to normalize it on 0, 1. So that'll be elapsed. So elapses from 0 to 0.75. So that we know it'll be in the 0.25 to 0.5 range. So we'll do return elapsed minus second phase dot second dot range dot lower bound. So we want to sub out 0.25 and then divide it by, I think that, and then we can figure this out. So okay, I think that should do it. And then kind of we're gonna, sorry, that's a lot. Well, it's probably not right, but we'll figure this out. So trim end, and then we kind of want to do the same dance here. Trim end. So now so it's a third phase contains it, we want to return 0. Yeah, so let's take this one step at a time. So if we second phase dot third dot range dot contains elapsed. So we want to make sure that that's not the case, else return 0. And then if we're in the and then same thing, if we're in the second phase, we want to return 1. And then else we're going to be, if we're in the first phase, so that'll be, if we're in the first phase, upper bound, I think we don't need to subtract anything out. And then we just need to normalize it on that first phase's range. Cool, so let's give this a try. This is probably not gonna work, but let's see where we're at. So fading in and out. Okay, so we're going from left to right, but we're not having the tail follow. So let's figure out what's going on there. Oh, you know what? It's probably Probably the parentheses here. I think this is literally PEMDAS messing me up. Okay, let's see. There we go. This is programming for you. Cool. Sweet. So now we can take out that print. Oh, what the hell happened there? Cool. So now if we run this, we have fade in and out, and then running across the track. And it hard cuts out now, but we can kind of pause it there. So yeah, this is a rough sketch of how we did the implementation, and there's actually a lot we left out. So this is kind of where we encourage you. I'll share this code in a gist below, but this is just the start. So there's some other things that we needed to handle were like color scheme awareness, making sure that if we interrupt the animation mid-phase, it kind of properly ends and like completes out. If you want to have this be driven by Swift concurrency, so for example, when we did like the phase interrupt handling, we did that all in combine. Doing it Swift concurrency can be a really cool exercise. And also there's a lot of nuance in terms of like how this is placed within Arc. So for example, for those of you who are not familiar, we have vertical split view. So if I open up a vertical split here, you may notice if I like refresh this, we have like the grabber for the resize handle in the vertical split become the loading indicator. And there's also trickiness around like little arcs. So for example, this is a little arc window. We actually have the loading indicator pop in under the URL host and have it animate in, and then when it fades out, kind of bring the URL back. So lots of little nuances, but we encourage you all to try and take a swing at this implementation. And really curious to see what you come up with, and hope you enjoyed the new loading indicator. Alrighty.